Hello and welcome to iLearn Review Day 9. Today we're going to take a look at exponent rules and work on problems 76 through 91. So if we look at problem 76, we have 2x to the third times 6x to the third. When it comes to exponent rules, there are several of them. The one that we're going to look at for this problem is called the product rule. And so the product rule deals with multiplying things that have the exponents. And what happens is, if you multiply two things that are the same, for example, x to the first times x to the second, all you do is you keep the variable the same and you add the exponents. So 1 plus 2 then makes this x to the third. So that's called the product rule. You're adding the same. Well, let's take a look at our regular problem. So the first thing we can do is our coefficients here, we can just multiply those together. So 2 times 6 is 12. And then we'll take a look at the variables that have the exponents themselves. So x to the third, x to the third. So this is going to stay x, and then 3 plus 3 is 6. So the answer that you're looking for to simplify this is 12x to the 6th. Let's take a look at number 77. Number 77, again, is the same thing. Always remember that when there's not a number there, we can assume that there's a 1. The same thing is true for the exponents. So 8 times 1, so 8 times 1 is simply 8. K is going to stay the same. And then we take a look at, okay, k to the third and k to the first. If I add those together, I get k to the fourth. And then this problem has now been simplified. Let's take a look at problem 78. Again, the same thing. The first thing you're going to do is look at the coefficients first. 3 times 8 is 24. M is going to stay the same. And then we're just going to look at these here. 4 plus 4 is 8. Again, that's called the product rule. You're multiplying variables that have the same exponent, so you simply add the exponents. 79, again, we're going to look at the coefficients first. So 7 times 5 is 35, times 2 is 70. And then n is going to stay the same. Remember that there's a 1 there. And so now we're going to look at the exponents. 4 plus 1 is 5, plus 4 more is 9. Again, that's called the product rule. Looking at problem 80, we're going to look at the quotient rule. So what that says is if we have b to the fourth over b to the second, we want to have all of our variables on the same side of the fraction bar. And so what you should notice is, see how this one's smaller? 2 is smaller than 4. So you're going to subtract. So this is going to cancel out here, and it's going to become b to the second, and that's over 1. And remember, anything written over 1 is just going to be itself, so b to the second. Let's take a look at number 80. So 8 over 7, I can't divide that, so it's going to stay 8 over 7. However, I've got a b to the second and b to the third. Because b to the second is smaller, I'm going to move it down here to the bottom. I'm going to subtract 2, and this is going to become b to the first. However, I don't have to write the 1, so you can simply leave this as 8 over 7b. If you write the 1, it's still the correct answer, but you don't have to write it. Number 81, again, the same thing. I cannot divide 3 by 5. So k, this is a 1. We're going to move it to the top and subtract 1 from up here. So this is going to stay, k is going to stay on the top. It's going to become k to the second. Again, that's called the quotient rule. Let's take a look at number 82. Same thing. I can't divide 8 by 6, but here is something interesting. I can reduce this to where it is 4 over 3. And so x, this is a 1. I'm going to move it to the top. It becomes minus 1. 3 minus 1 is 2. So, again, the quotient rule. Again, we're looking at the quotient rule this time. So, this time I can divide 8 divided by 4, or I'm sorry, 8 divided by 2 is 4. And so this goes away because we've worked that out. And then we want to move this up here. So we're going to subtract 2. So x is going to stay on the top. It's going to become x to the first. Again, you don't have to write the 1. And notice how there's now nothing on the bottom. When that happens, we assume that there's the number 1 there. This is going to reduce to 4x. Let's take a look at number 84. So this rule is called the power rule. And it would be like having 2 to the x in parentheses. We'll put an exponent of 2 there. With another, let's say, 4 out here. Now, the 2 still has an exponent. It's 1. We just don't write it there. So you're going to do 2 stays 2. 4 times 1 is 4. So this becomes 2 to the 4th power. X is going to stay x. 4 times 2 is 8. So it becomes x to the 8th. Again, you're going to multiply a power to a power. It's called the power rule. Now, but we can still finish and simplify this out. So 2 to the 4th power, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So this is going to become 16x to the 8th. Same thing here. The 3 has a 1 with it, so 3 times 1 makes this 3 to the 3rd. 3 times 3 makes this p to the 9th. However, I can do 3 to the 3rd. So 3 times 3 is 9. Times 3 again is 27. P to the 9th. And this is the answer you're looking for. Again, that's called the power rule. You multiply your exponents. Let's take a look at 85. This time we've just got k, so we're going to multiply this. So we're going to be left with k. 4 times 3 is 12. That's as far as you can go. Same thing here. There's a 1 there and a 1 there. So you're going to have 6 to the 2nd and p to the 2nd. You're going to multiply the exponent by the exponents. So 6 squared is 36. P to the 2nd stays p to the 2nd. That's simplified as far as you can go. 87. Again, you've got a 1 for the 5 and a 1 for the x, so this is going to become 5 squared and x squared because you're multiplying. And so 5 squared is 25, x stays x squared, and that is simplified as far as you can go. Looking at problem 88, we have a negative exponent. This is called the negative exponent rule. And so what happens is we don't like negative exponents. So this is the negative exponent rule. And we want to make that a positive. So if we have x to the negative 3rd, what's going to happen is this is just going to be, we're going to flip it upside down on a fraction. So this is going to become 1 over x to the 3rd. Now let's say it was 1 over x to the negative 3rd. We would change that to x to the 3rd over 1, which would then reduce to x the 3rd. So you're going to flip it to the opposite side of a fraction bar. So when I see v to the negative 4th, I know that it's written over 1. So what I can do is just flip that. 1 over v to the positive 4th. There we go. And that's simplified as far as you can go. Take a look at 89. 7 is just a number, so it's going to stay the same, but I want that y to go to the opposite side of a fraction bar, so y to the fourth goes to the bottom. By flipping it to the other side of the fraction bar, it becomes positive. Let's take a look at number 90. So again, 7's positive. It's got a positive one there, so it stays on top. X has got a negative exponent, so we're going to move it to the bottom. And then y is already positive, so we just leave it right where it is. This is simplified as far as you can go. Looking at 91, which is our last problem for today. Again, 7's still positive, so it stays on top. The exponent's positive, it's a 1. M is not, so it gets moved to the bottom, becomes positive. N is already positive, it stays on top. Again, that's called the negative exponent rule. That completes today's iLearn review for day 9. Tomorrow we will take a look at how to write in scientific notation and then how to convert from scientific notation back to regular numbers, and then also how to determine whether or not an object is bigger or smaller based on scientific notation.